Welcome to Easy Aid Tutoring. Let's have a quick look at how to prepare your lab book. A prepared lab book is a powerful learning tool, and a typical outline is having an aim and objectives, background theory, this is typically written in your own words, key chemical equations, safety hazards and PPE, a list of reagents and apparatus, an experimental setup, a concise procedure outline, prepared data tables. This is where you record your values and your quantities that you acquire in the lab, preliminary calculations, and a section for questions if anything while preparing was unclear or confusing. Now for this example, I used tetraamminecopper 2 sulfate monohydrate to set up this lab book. First, we have our aims and objectives. Our aim is just what's the goal of the experiment, and our objectives are specific steps that we need to reach or to do in order to achieve our aim. And the background, that's typically written in your own words, can include historical information about the compound that we are producing. It can include some experimental background. You can also add potential uses or even things to be careful of for a specific compound that you are synthesizing. Next, we look at our chemical equations. Now, you will see that this one is only one chemical equation. This is just because it's a simple reaction. Sometimes you will get something that has multiple steps. This means that you have more than one reaction equation, and it's also a good idea to always have these reaction equations balanced beforehand. Now, I also like to go and add the molar masses of all my reagents to this step over here, because once it is done, you can check it off a list and move on, and then you can always refer back to it because you know it's there. Next, we go and have a look at our safety hazards. Those safety hazards are just things that you need to watch out for during the reaction, and these usually are specific to reagents or even experimental conditions. PPE is typically your basics, your lab coat, safety glasses, long pants, closed shoes, and sometimes depending on the reagents or the reaction conditions, you might need some specific type of PPE. Next, we go and have a look at our reagents. Now, what I like to do is if we have more than one main section in our procedure, for example, in this experiment, we have two, so we have a product synthesis and an ICP sample preparation. I do like to go and separate these into two different tables. It's not necessary. Now, the quantities that we have here, this is just typically you go and read through the method in your experimental guide, and these quantities you get from there. So you know that when you step into the lab, you need to go and weigh about 5 grams of copper sulfate pentahydrate. Next, you'll see I like to add a roll column as well, so that you know why I'll be using a specific reagent. And this is beneficial because sometimes you may need to mention what the role of a specific reagent is somewhere. Next, also from your method in your experimental guide, you get your list of apparatus. And this is very beneficial because once you come into the lab, if you make sure that all your apparatus is on hand before you even start with your experimental setup, this saves you quite a bit of time. Now, our experimental setup. This isn't always necessary, but I like to add it because if it's something, for example, you're just heating your reagents together, you know, that's quite simple. You don't need to see an image of it to make sure that you're doing it correctly. However, if we are doing something like a distillation setup or a reflux setup, you might not always remember how to do it, especially if you are new to this technique. And then it is very helpful to have it, you can either paste in a printed out image, or you can hand draw it in your preparation book, and then you can just refer to your preparation book once you need to do that specific setup for your experiment. Next is our procedural outline. So once again, this experiment had two sections, so a product synthesis section and an ICP sample preparation section. I like to split these into two different sections so that you know that what the focus of each method is. And typically I like to do it as well if these two don't follow directly on each other. For example, if you have to wait a while for your product to dry or whatever. Now, a very important tip that I can give you here is to leave some space when you write out these methods, because sometimes when you get into the lab, your demonstrator or lab manager can give you some tips on how to speed up the equation of the reaction, or how to be done quicker, or typical pitfalls that students always fall into, and then you don't fall into that pitfall, and it helps you to get through the experiment stress-free and quicker. Now you'll see here that I also added some additional information at my step 4 and 5. So sometimes you need to just add these little sections for yourself just to make it easier to know what you need to do. So for example, here we are preparing a solution A, we are using some of solution A to prepare a solution B, and we have to hand in solution B. So having little personal labels for yourself always makes it easier. Now, something that I've also seen students do, which is quite nice, so if you function better or think better if you are looking at a diagram or image instead of just a list, you are more than welcome to also draw this in as a diagram instead of putting a list here. That would be dependent on yourself. Now, something that I do like to add is a little section that says what to report. So what is expected of me after I do this experiment, and then report on it. This is quite important for me, because you then know what type of calculations you need to prepare for. And it also, if you aren't sure of these calculations, you know, you can always ask a friend, a lab manager, someone who knows these techniques better than you. If it's not given to you in your experimental guide, you can also just leave a space, and then once you get this information, you can write it down there. Now moving on to our prepared data tables. Now, I like to prepare these data tables beforehand. So for specific type of measurements, the quantity, now this quantity is the quantity that you get in the lab. So for example, this is now that 5 grams that I go and weigh off, and then this is, you know, weighing it off accurately. So for example, if I weighed off 4.998 grams, that is what I put down here. Now you'll notice that I also have a moles and conclusion column here. This is typically when you have more than one reagent that actually influences the yield that we will get at the end. You can go and calculate the moles of each of these, and then you need to go and determine the limiting one, and then I just like to note that under conclusion. Another very important thing that you will notice here is the filter paper. So I added the filter paper here because It's very important to weigh your filter paper before you filter your product onto it, because how else are you going to know what the mass of your final product is? Other things that can also be added in place of the filter paper is sometimes you will leave your product to form in a beaker, and then you would need to know what the beaker mass was before you weighed your, or before you added your solution or whatever in there to form your product. And sometimes it can also be something like a pear flask. So it's important to write this down so that you can accurately know what the mass of your product is to go and do accurate calculations afterwards. Now, I like to do these preliminary calculations as you go write down the skeleton of your calculations that you need to do. So this is essentially all your equations written down with the necessary information, or the information that you already have. And then once you're in the lab, you can add your information that you've acquired in the lab. And sometimes, for example, if you now have something like your moles, you can see that I have already written in my molar mass here, and this is where it comes in handy to already have your molar mass calculated like I had under my equations. Next thing is, you can then, once you're in the lab, if there is a step or a place that you wait a little time for something to happen with a reaction, you can then start doing calculations, for example your theoretical yield, because once you have what you weighed off, the moles that you need and for your final product, then you can already go and do these calculations. So finally, as I mentioned before, under the what to report section, we know that we need to go and report our percentage purity of our copper in our final product, and we also know how we prepared our ICP sample. So for example, we weighed off a specific amount that we dissolved in 250 milliliters of molecule water, so we can go and calculate what the mass in grams is of the copper in the 250 milliliter solution, and then we move forward with the next steps. So that is why I find it very useful to have these backbones, these skeletons of the equations already written down. Now, once you're in the lab, and if you have someone that checks your lab book once you're in the lab, it's also useful to already have this set out, because when they check your preparation, they can have a look at these sections, and if you've made an error somewhere, they can help you fix it, so that you know that once you leave the lab, you already have everything well set up so that you can do your post experimental analysis correctly and add correct results into your report. Finally, I like to have a little questions section, so if there was anything that I found confusing or unclear at any point during my preparation, I would put them down here, because you never know if you are going to remember any questions that you had when you were preparing by the time that you see the person that you can ask. Then you add signatures if that is necessary, and that is your lab book. Thank you for watching. I hope this was useful. Please like and subscribe for more educational content.